Hello, I'm Carden Baylor, and I'm here to talk to you about pathfinding in the New York City subway using Graph Analytics for Snowflake. To set the stage a little bit, the New York City subway, or the MTA, is the largest in the country. 3.6 million Americans ride the subway every day. That's 1.3 million more people that ride the subway each day than take a flight each day in the United States. And that system operates 24/7. It's probably the largest in the world that operates 24/7, introducing a lot of operational complexity around it. So today we're going to be looking at how a closed station ripples throughout the entire system. New York City is unique in the number of riders, stations, and the level of service it provides, and by using Graph Analytics, we can easily model what would happen if a station were to be fully closed for repairs. And the type of thing that we're modeling here is specific to the New York City subway, but it can also apply to things like supply chain or manufacturing processes. So in the same way that a subway station might close, a supplier might go out of business, or they might raise their rates and you need to find an alternative path through your supply chain. So keep that in mind as we're working through. So how do you perform graph analytics? Well, first you start with the Snowflake table, then you run an algorithm after you project it into an in-memory graph, and then you run the algorithm. You write your results back to a Snowflake table and in your session, and the billing will stop just then. So let's jump into the algorithm explanation. So the algorithm we're going to be using today is called Dijkstra's algorithm. So let's imagine you have a set of nodes, A through F. They could represent anything, but in our case, they can represent subway stops. Our algorithm will calculate the distance between A and all other nodes, rather than just the shortest distance between A and F. How will it do that? So you're going to start at node A, and this is a greedy algorithm. So it'll look for the neighboring nodes, and it will go through this kind of a table and update what the shortest distance back to A is. So A is our starting node, and the first node we're going to be looking at is actually A, and the distance between A and A is 0. So that's a little perhaps obvious there. Then we'll start looking at its neighboring nodes. So the distance between A and C is 2, and the distance between A and B is 6. So we'll update our table here. Next, we'll go to C because it's the shortest node, and we'll see what's the distance from the nodes neighboring C back to A. So from B to A, it's either 6 or 5. So we'll update this to 5 from 6. And from D, it'll be 10. So the next shortest node to go to would be B. Now we're at B. The only unvisited node at this point is E. So from E back to A would be 4 plus 3 plus 2. So what's that? 9. So from E to A, it'll be 9 back through B. That makes sense. So the next one will be F and D. So for D, the shortest way back will be 10. 8 plus 2 is 10. And from F, it would be 12. So we update the table there, and you have all of your distances. To get to F, you go through E, from E to B, from B to C, from C to A. So what does that look like in Snowflake itself? First, you'll go and you'll download the app from the marketplace. Again, this is a Snowflake native app. You'll start by loading in your data. Our example will be using some CSVs, one for nodes one for stations called stations, and one for lines called lines. I suggest just using the GUI to load them in. Next, you're gonna have to kind of set up your notebook. You'll switch to the account admin role, then you'll grant a bunch of permissions to the Neo4j Graph Analytics application. After you do that, you'll switch to one of the roles you just created, and you'll begin cleaning your data. Cleaning it will be pretty simple in our case. It looks like this. We have stations, and then we have a separate one that's lines. We can take a look at that now. It might take a second for it to start up, so I'll just keep going through. For the stations, all we're going to do is we're going to rename the main column to node ID. That way it works correctly. And for our lines, we have source node and target node. So we're pretty much already there. We're just going to keep these two columns. which we'll do here. Then we're going to run our algorithms. So the algorithm we're running today is Dijkstra. I think we went through that. You'll include what the source node is, what the target node is, and what the tables are for those, as well as a relationship table. So it'll be relationships and then the node table. You'll say what your source node and target node is. In our case, we're going to be starting at the Bergen Street metro stop in Brooklyn, and we'll be going to Times Square. So you do that, and you'll get a result that looks like this. You'll also be specifying where the table should output to. After that, you can do a little simple SQL query to flatten it out and make it a little easier to read. And we also make sure we include the order. So we have Bergen to Atlantic to Canal to Union to Herald to Times Square. I'll say in this simple model, we're not considering wanting someone to stay on the same line. So it's being kind of aggressive with like line changes. So I think it like starts on the 2 and goes to the Q and so on. Now we're going to model a disruption. So what if one of these stations were to close completely and like, Herald Square all of a sudden like flooded and no one could use that station? What would happen? So we're going to remove that node both from our nodes table and create a new table called nodes filtered, and do the same with relationships, where we take that out of both the source and target node. Then we'll run our algorithm again, exact same algorithm, different nodes and relationships, basically just excluding that one station. Run it again, and we get our results back like so. So we added another stop, essentially. Like I said earlier, this doesn't necessarily have to apply just to subway stations. You could have a similar setup where you're looking at different suppliers and one of them goes out of business or is blocked or, signs a new deal that you don't like or whatever. And then you can exclude them from your supply chain. And instead of doing the, shortest distance between, it could be the cheapest path. That could be your relationships. So this is a really powerful algorithm for helping you navigate a chain. And yeah, it's available now, so give it a try.